Ricky here, and you're watching Ricky Talks Shop. Today I'm working on a way huge Red Llama clone, which in itself is a clone of the Tube Sound Overdrive from Craig Anderton's book Electronics Project for Musicians. If you're interested in this at all, I would definitely recommend a copy of that book. It's great. This project started because there was a guy on a Facebook group I'm part of who posted that he had a pedal that was homemade. Somebody had made it. He didn't know what it was, and he felt it was kind of unique, and he wanted to find out what it was and have somebody clone it for him. So I thought that sounded interesting. So he mailed me his original pedal right there, and I went through it, and first off I have a schematic here, and this is from Beavis Audio. So any part numbers I reference are the part numbers on this particular schematic. If you Google it, you will find this. It's a pretty good schematic, so thank you to Beavis Audio for providing that. So his pedal, it's totally stock, except for this R4, which is a 100K resistor. On his pedal, it's 10K. And what this does is this sets the gain for this stage of the circuit. So a smaller value part decreases the gain, and a larger value part would increase the gain. It's way more common when people mod these that they'll go to a bigger value like 500K or 1 meg. I've even seen people use 10 meg. And we're not going to go that direction here because it's not what my customer wants. But I did experiment yesterday with this, and I put a 1 meg resistor in there, and it did pump out a lot more gain, but the gain control itself got pretty useless. It didn't, whether it was all the way down, all the way up. So if you're making this bigger, this R4, you may need to look at the value of your gain pot and figure out what's going to work so you can adjust your gain some. But here I'll show you. I have this wired up with some switches, so we can just flip back and forth between some parts. Here's the pedal, dead stock with the 100K resistor. Now we'll switch to the 10K. It's a little different. I don't know how well you can hear it through the camera mic, but in the room it is a little different. And that's with our gain a little more than halfway up. But I'll show you what this does with it all the way down. So we're back on our stock part. There's gain all the way down. And we'll go to our 10K part. So very little output. We'll turn the gain up. So it does make a difference, but the higher the gain is set, the less it matters. I'll talk to my customer, see which way he prefers it. Really, I mean, unless you're using this for some pretty low gain stuff, I would personally probably rather go with the 100K, but you know, it's all in personal preferences. The next part we're going to mess with, I'll show you here again on the schematic. This is part of the power supply. So we have our 9 volts, and that comes into a 1K resistor, which is labeled R1. And then we have D1, which is just a diode. And what this does is it only lets power flow one way through it. So if you were to hook up a reverse power supply like a negative 9 volts, it would just filter all of that current to ground. It's just a protection circuit so you don't damage your IC chip. And then there is a capacitor, C1. On this schematic, they had it as 100 UF. Most of the schematics out there, it's 330 UF. I do not have this part on my board, but when I build the pedals, it'll be there. The reason I don't have it is just to, because I have a good regulated power supply, and it just makes my breadboard a little cleaner without it. And all this does is it acts like a quick charging and discharging battery, and it absorbs any fluctuations in your power supply. So if you have a cheap wall wart power supply or plug into bad power somewhere, this is gonna just filter that and clean up your power. You do see some people online saying that they change this 330 UF part to 100 UF and it makes their pedal sound better. That's nonsense. This is not a part of the signal chain at all. It is just a filter in the power supply. Either value, 100 UF, 330 UF, either one is going to work fine. Let's go back to this R1, this 1K resistor. That's a dropping resistor, so it drops the voltage. Now my power supply measures right at 9.1 volts. And with the 1K part on the other side of this, I get 5.6 volts. So it's dropping 3.5 volts across that. So we're not feeding the pedal with a lot of power. I did some experimenting, just some recommendations off the internet. 100 ohm resistor seems to work really well here, and that drops it down to 7.9 volts. So it's only losing 1.2 volts, and it feeds the pedal much better. And I'll show you that here. So there's the stock. So there, that's way better. Just changing that voltage that's feeding the pedal. It's a lot punchier. It's more defined. Now check this out too. With the higher voltage, that switch on that resistor in that gain circuit makes more difference with the higher voltage. So I'm definitely gonna talk to my customer, see what he wants in that gain circuit. But I am gonna recommend this elevated power supply. And another thing too, one of the big complaints people have with this particular circuit is that the low end can be really kind of fuzzy and nasty. So if we go back to our stock part, that's just on the low E string. Now if we jump our voltage up, again, I don't know how much is coming through the camera mic, but here in the room, it is a big difference. That low end is a lot cleaner. It's a lot more defined. So a lot of people will change other capacitors and stuff in the circuit to try and clean that low end up, but this works really well. All right, the next thing we're going to look at is the customer wanted me to try and see if I could make this a little more bass friendly. So most people will try to tighten up the low end on this. He wants more low end. So again, it's not a circuit that's known for having great low end. I don't know how well it's going to work, but we're going to play with it and see what it does. I'm going to change a few things on the breadboard here, and I will be right back. All right, I'm back. As you can see, I've replaced, I'll show you the schematic first. I replaced this first capacitor, this C2 68NF or 0.068. And I've put two capacitors on a switch. I have a 0.1 and a 1.0. So on this part, going to a smaller capacitor, like 0.047 or 0.022, that'll tighten up the bottom end. Going to a larger capacitor, like the 0.1 or 1.0, is going to allow more low end through this part of the circuit. Next, we'll look at this C4, which is 0.033. And we're going to play with 0.047 and 0.068 in that spot. So those are, we'll do these one at a time. So let's start with this first one. And I'll show it to you first. So here I've got the 0.1 capacitor wired in. And the big thing we're looking here is, does the low end stay defined, or does it just get mushy and grainy and sound like crap? We do have the elevated power supply too going on. Okay, so it's a little fuzzy, but it's it's still usable. It's still a defined kind of sound. Now we'll switch to our 1.0. Okay, on that one, the bottom end is a little kind of farty sounding, so that might be a bit much, but we can stick with that 0.1. Yeah, so that's good. We're going to go away for a minute, and I'll switch in some switches, or some capacitors on a switch for the second value, and we'll see what that does. All right, we're back again. Now you might notice we are starting to get some noise, some hum. A lot of that is because we're just parts and wires hanging out in the open here. There's no shielding, there's no case around it. It'll all be quieter once it's built into a pedal. Now again, we've replaced this 0.033 C4. I have a 0.047 and 0.068 on a switch. And we're going to try that and see if our we'll see if our low end is starting to get nasty. So let's check that out. So it's it's getting a little fuzzy, but I think that's kind of what my customer is after a little bit. So it's not a bad thing. Let's switch to the 0.068 to the bigger capacitor and see how that does. All right, there, it's kind of starting to fart at me a little bit. So we'll go back. Okay, and we'll try switching back our power supply. So that does, switching that power supply does add quite a bit of gain. So I'm gonna mess around and see if I can match the gain level by just adjusting the gain pot, but still keep the higher voltage punchy tone going on. Switch. Okay, so that felt pretty similar gain-wise, and it's still more punchy, more defined. I feel like that's at a pretty good place right there. I'll talk to my customer, see exactly what he wants me to do. He wants me to build 4 of them, so I don't know if he's going to want them all the same, or maybe we can do some different versions of this for him. We'll see what he wants. But I'm gonna go through this circuit with you now if you're interested in that. Kind of show you what things do. We looked at this power supply. There's really not much to it. The only thing you're really going to affect is the value of this R1. And changing it does affect the gain, the tone, the punch, the brightness. So it may be worth experimenting with some different values, find what works for you. Now looking at our circuit, again, the big mods people do to this are trying to clean up that low end, which is changing out this C2 and C4. Again, normally people will decrease the value of these capacitors to tighten it up. We went the opposite direction here, and I was able to bump this 0.068 up to a 0.1, and this 0.033 up to a 0.047. Anything bigger than that, and it just got really farty sounding, and it's not really usable. You could also mess with this C6, which is 10 UF, that output capacitor. The next capacitors, well, next let's look at a gain stage. So another thing too with this pedal is this is not a normal op-amp chip. This is a digital CMOS hex inverter. So definitely worth reading up on how those work, because it is not like a normal op amp at all. You'll notice this circuit has no diodes, no clipping devices, because all the distortion happens within this hex inverter. So it's definitely not just another Tube Screamer clone. So now if we look at this gain stage, so what happens is when our signal goes into this pin 14, it comes out of phase, out of pin 15, out of phase. And what this circuit feeding back does is it feeds some out of phase signal back, and it cancels out some of the signal here, and that's how you adjust your gain. Is if you send more out of phase signal back, you get lower gain. And that's what this 100K resistor and 1 meg pot do, is they change the gain. We also have, quick again, if you increase R4, you get more gain. If you decrease it, you get less gain. Then we have a 51 PF capacitor. And what this does is it sends some of the high end back. So you're always filtering off a little bit of your really high end frequencies. These are usually in place to control noise and oscillation and things like that. With this, because this uses a digital chip, it could be some kind of digital noise it's filtering out. If you want to brighten your pedal up a little bit, you can play with decreasing the value of that. But you may get some mixed results. Because I personally find that these kind of parts are usually there for a reason. But that is something you can play with. We come to our second gain stage, which uses a larger capacitor here, 100 PF. Again, you could maybe brighten things up, get some more top end by changing the value of that. And this one doesn't have an adjustable pot. This just has a 1 meg resistor feeding back to set the gain level for this stage. That's really all there is to this whole circuit. It's really very simple. There's not much to it. I will, like I said, I'll talk to my customer, see exactly what he wants me to do, and then I'll get his pedals built, and I will post a follow-up video and show you what we come up with. So until then, thanks for watching. Let me know if you have any questions, comments. Thank you.